Okay, picking up where we left off, we're on page 279, talking about things like file and print services. So here's basically how it is. I have a computer over here, and I have a server somewhere that has a file, and so the file gets translated. This is kind of a dumb diagram, but I ask for things, and the machine provides the files that I need. So if I had an Excel spreadsheet that was stored on a network share, I just ask for it, and presto changeo, it gets downloaded to my machine where I can deal with it. Okay, that's basically it. Continuing this whole concept of philosophy, we're going to talk about the client server model. Okay, client server model basically says that I have a server, and then all these other machines talk to it. So I could have several clients talking to a single server. So this is typically the way it works in corporate America. You have maybe like a server room, and these are PCs that they're just robust PCs. I mean, there's not that much difference between the PC in the server room and the PC sitting at your desk, other than they're more robust and probably have a lot more storage and a little bit more sophisticated network cards and things of that nature. But they have like horrible graphics cards because like nobody's going to be running games or anything on these servers. Okay. And you're going to have a handful of them. And so I'm going to have like one for doing file serving, and then one for maybe SharePoint services, if you know what that is. One for doing like email. And one maybe like for doing a database. All right, here's the idea. These clients are probably, PCs in their own right? And so they can most likely process everything you need. No. There's some scenarios where client server just absolutely positively makes sense. Let's talk about email. I do not want my email to be stored on my machine. All right, think about that. So, in your home, let's say your email was stored on your PC, okay? And so you turn your PC off and at night, and no one could send you email at all until the next morning when you turn your machine on. Wasn't that kind of dumb? Wouldn't it make sense for that email to be stored in a central email server someplace? Most likely at your internet service provider, not a server that you manage. So this server is on 24/7, and it goes centralized. So that's client server. Every time I fire up my email client, fire up whatever it is I'm using, Thunderbird or Outlook, and it connects to the central server in the sky somewhere and pulls my email down. So we definitely need client server. I cannot process everything, and I do not want to process everything on my machine. I need a server. Okay. Another example is a database. Yes, I could have Microsoft Access Database on my machine. You could have Microsoft Access Database on your machine. But when I add a record to mine, it's not going to add the record over here on yours. So wouldn't it make sense if we all share the same database? So client server is all about those scenarios where I want to have one copy or one location of something that we all share. So one email server, one database server, and everyone connects to it. Got it? Okay. Let's just go through these advantages and disadvantages because it essentially says what I said. It talks about, and this is a kind of a goofy little figure here, or table, 6.4, because it really kind of looks like it from a historical perspective. Like maybe you're trying to decide whether or not to convert from, an old server scenario to a client server scenario. And of course, in reality, the dumb terminal days are long gone. So a lot of this is not going to make any sense, but let's just go through it. It talks about moving applications of the mainframe to the terminal to host architecture can yield significant savings. Yep, that's true. The disadvantages is this could take an awful lot of time. Okay. But hopefully that was done like 30 years ago. Minimize traffic on the network because the data only needs to satisfy the user's query. Now this is a little weird. Okay. Let's say I have a giant database in the sky that has the names and addresses of every person in the state of Texas. If that was on my PC, I could go in and I would have to have a big enough hard drive to store that entire thing, right? But if it's on the server, and I say, give me all the people in Bell County. So what I've done is I've broken it down. So now it sends across the wire, not the whole dang database, but just the pieces that I'm interested in. And so if I'm always doing that, well, then I don't need to have an awful lot of memory in my machine. Don't have to have an awful lot of hard drive in my machine. It don't necessarily need to have a huge network cable to connect the two together, because I'm only pulling the parts that I need. Okay. This, unfortunately, gets a little complex because now I've got security issues. Now I've got 2 points of attack. Well, actually, more than two. I've got somebody could be breaking into the server, or somebody could be breaking into any one of the hundreds or perhaps even thousands of PCs I have in my company. So yeah, that's a little dangerous. Then it says security mechanisms can be implemented directly on the database. Yep. Over here, it's like, yeah, I just mentioned it. More than likely, you're going to have in a client server. You know, you're probably not going to have all the same vendor involved. You know, like you're going to have Microsoft on. Maybe you have like a Microsoft Access database that's connecting to an Oracle database, right? Or something weird like that, where you have two different vendors involved. And so, you know, who's to blame for security and who's to blame for, you know, updates, and it gets a little complex. Okay. Again, this is mostly from a historical perspective because most client-server conversions have already been taken place quite some time ago. Okay, let's continue. The next thing we're going to talk about is hardware. Okay, the term modem used to actually mean something. It was an acronym. I guess that's what you'd call an acronym. Anyway, but I'm not even going to tell you what it means because it doesn't matter anymore. The idea is it's a term that's been just overtaken with popular culture. And so officially it now means any type of network attached device. Okay? It's a thing that basically connects your machine to a network attachment device. That's good enough. Okay. Now some other terms. Well, okay. Here's a good one. So I have my computer, and then I have some sort of a connection that goes to my router, and it goes to a cable modem. And the cable modem goes all the way down, and it goes to your cable modem, and your cable modem sends it directly to your router, and your router connects it to the PC, and so that's how it all works. It used to mean digital and analog, but that's not really all that relevant now. Okay, here's some other terms that we need to talk about. A router. So what does a router do for a living? A router is a thing that connects two networks together. That's what it does for a living. It takes my network in my house and connects to the internet, or it takes the building 1, 2, 3, 4 and connects it to building 4, 5, 6, 7. Okay? Purpose in life is to connect two networks together. That's what a router does. Okay? Got it. There used to be a thing called a hub, and I'm going to go ahead and talk about a hub just a minute. A hub was a dumb device, and what it would do is when I sent a packet to a hub, it didn't look at the packet. All it did is it got it and just blasted it out to all the rest of the people. So let's say I had 100 people connected on a hub. One guy sends a message. Okay, it was only intended to go to machine number 42. That's its intent. Okay, I send it to the hub. The hub says, I don't know who the hell 42 is, so he blasts it out to all 100 computers. Now, number 42 says, oh, that's me, and he listens to it. Everyone else says, that's not me, I'm going to ignore it. Okay, and that's very inefficient, as you can probably imagine. Why am I sending it to 100 machines when it was intended to only go to one? So hubs practically don't exist anymore. If you went to a networking place, went to a consumer electronics place, and you said, I want a hub, they would say, we don't have any of those. We have instead what's called a switch. And a switch is basically the same thing. A switch is going to have lots of places where you can plug in. So I have like a 5-port switch, so I can plug 5 devices into it. But when device number 1 wants to talk to device number 5, it looks at the packet and goes, look, I'm not going to send this to everybody. I'm only going to send it to the guy who's intended to. Like, wow, how come you didn't think of this to begin with, kind of thing. So it only transmits it to the other guy, and none of the other people get to hear that conversation because it's not required. So switchers are smart. They send only to the people where the traffic is intended. Hubs are dumb as rocks and send it and just block. It's more like those people who do the reply all to an email. You know what I'm talking about, right? And there'll be an email storm where somebody does reply all, and you go, oh, geez, not everyone needed to see that, right? Okay, that's what a hub does. A gateway. A gateway is basically a router, and some people call this a gate router or gateway router. Gateway is basically a router that connects to an outside network, most likely the internet. So in a corporate environment, you would have a router between buildings, and then you would have what's called an edge router. Okay, the edge is that gateway. The edge means I'm now leaving the confines of my network, because my network may be connecting like 3 buildings together. So I'm leaving the confines of mine and I'm going off to somebody else's network for which I have no control over whatsoever. So the edge router, the gateway router, or the gateway, 3 terms describing the same thing, is when I'm connecting 2 networks together, but most likely one of them belongs to me and one of them don't. That's the difference. So they don't look that much different than a router. It's just how they're being used. Okay. Wireless access point, yeah, everyone knows what that's about. Okay. In the old days, well, actually not. You have this kind of a thing called a multiplexer. And a multiplexer is kind of a weird thing. An example of a multiplexer is a private branch exchange. Let me explain that, for example. Let's say that in your building, you have 100 people and 100 phones, okay? Does that mean that I have to go to my local telephone company and I say, I need 100 pair phone cable coming to my building because I want everyone to have a phone, right? And I have 100 phones, so therefore I need 100 pair cable coming to my building, right? Well, in the old days, the answer was yes. That's exactly right. And the phone company is going to go, ha ha ha, great, because they're going to sell you that 100 pair cable and they're going to make a lot of money. So instead of doing that, you could sit down and figure out, okay, look, I've got 100 phones, but they're probably not all going to be used at the exact same time. How about 25 of them are going to be used simultaneously? You pick a number, let's say 50, okay? 50 of them are going to be used simultaneously. What we'll do then is we'll buy a 50 pair cable at a significantly reduced price than a 100 pair cable. So I'll get a 50 capability cable coming to my building, and then I'm going to hook it up to what's called a multiplexer or a private branch exchange so that it fans out. So when I pick up my phone, there's a little delay there, and he goes, hang on a second, let me connect you to one of the available lines. And so the next guy picks up his phone and says, hang on, I'm going to connect you to available lines. And eventually, if the 51st person picks up the phone, he's going to get a circuit not available thing because all the lines are in use. Okay, that's how. And people used to use these to save lots of money. You could buy a system, install it, and then reduce the phone bill coming into the service. You could cut your phone bill in half by spending a couple $1,000s on installing a branch exchange. So that's what multiplexing. Multiplexing basically reduces the requirement for inbound and outbound channels. Okay, that's what it's all about. All right. The next thing you talk about is the software piece of this puzzle, the network operating system. Now, once again, in the old days, you're probably tired of me saying that, but I am an old fart, so I can get away with it. In the old days, you didn't necessarily have to buy your network operating system from the same people that was running the operating system on your servers. So you could go and get Novell software, and all it did was that's all it did, was just networking. So it was completely separate. And you can install that on top of a Unix box, or you can install it on top of other kinds of things. That's not the way it works now. But this is a good place to stop for the 15-minute mark, and we'll pick this thing up again in just a few.